Seattle hardware startup meetups. Hopefully we can continue to do it out here. Sorry, there's a few less seats than there are people. That's a good thing, right? Means lots of people are here. A lot of people are excited about this. Feel free to get up and grab whatever during the meetups. First off, I want to thank Hack.io for sponsoring this meetup. Thank you. That was a great guy. Another quick shout out to SoDo Makerspace. We are going crazy here today, getting ready for a day, so thank you very much to Eric and SoDo Makerspace. So today's going to be a little bit of a different format than I think you guys are generally used to. We're going to have 4 different speakers. We're going to keep it short, curt, and hopefully engaging. We're going to give you a brief overview of do-it-yourself prototyping, maybe micro-manufacturing, and kind of just get the idea of running in your head as to what you can do in spaces like this. So to start it off, here's Eric Wren, who's co-founder of SoDo Makerspace.
Thank you. Hello. Welcome. My name is Eric Wren, and about 2 years ago, I learned about makerspaces, and I had no idea what makerspace was. I'm still an entrepreneur, and I really am blown away by everything that's going on. And I'm excited that you're here. I have traveled around extensively for the last 2 years, kind of looking at other makerspaces, seeing how they work, and this is what I like, and this is the result. So we hope that you feel at home, comfortable, and welcome to the lab. So who's next? John's next.
All right, so like I said, we're going to go through a couple of machines, a couple of the more, I guess, lesser known machines. We'll say 3D printing for another time. Start off with laser cutting. So to start off, here's the actual machine. I don't know if it's still running right now, but I'll go back there afterwards and check it out. So we'll start with, I'll show you a quick demonstration of what is actually going on. So this is from start to finish, that's what I did the other day. So from CAD, you put the file into a format where you can actually start building layers. These are the layers about 1 cuts first, 1 cut second. Here is a little circle with a disc in it. So I write red one on there to kind of jog my memory because I'm making 40, 50 of these things. Now I'm setting the power and the speed level for the laser cutter. This is going to check how deep it's going to go, how deep it's going to go. I'm doing a quick coordinator test and seeing how I'm hitting the bounds. I'm going to actually get the cutting. Right now, this is engraving. This is the actual cutting, so engraving means I'm not actually going through the piece. Cutting means I'm actually going through the piece. Just kind of clean all that debris. And there's the finished product. I didn't need to see that word reveal, but here's the piece that I cut. So you guys will check out later. So this is acrylic, this is 8-inch acrylic. It's a really great material. It's a laser cut. How does the laser cutter work? And yeah, it is actually just a giant laser in the back that does the cutting. So there's a giant CO2 laser in the back that shoots into a series of mirrors. So the simulation is actually invisible, but you'll actually see a little red dot in there. And that's from a little plasma laser. So these mirrors move around to allow the laser from anywhere on this. Actually a 4 foot by 3 foot bed. What happens in there is the laser beam comes in there, goes to a focusing lens, and ultimately cuts the material. You just want to engrave the material, you put this focus point on the top, so it's very fine and clean, and it doesn't actually go through. Something to know here is that there is a curve, so you do get that hourglass-like shape, but if you have a very thin material like this, it's going to be very difficult for you to see that hourglass-like shape, but if you start getting into a thin material like a 3/4 inch ply, half inch ply, we'll get to it eventually, but the edge is not going to look very good. But if precise isn't the necessity for you, then we can still get it. The cutting versus engraving. So this right here is engraving. I know it's pretty complicated, you guys see this, but this is engraving. It's not all the way through. It's like this is an engraving. These are engravings. This is a cutting. This is the 2 very basic operations. You can do other stuff. This is called a raster engrave, where the laser cutter is more than each printer real time before. This is vector engrave, where the laser is following the output. Yeah.
On the left, the makerspace with the cut and the engrave, can that be done in the same way?
Yeah, so if you, in that series of layers, I had 3 different layers. I said, I want to cut out these holes first. I'm sorry, I said, I want to engrave first, then I want to cut holes first, then I want to cut out the overall thing.
So, like, you can change the focus point in the middle.
You can't actually change the focus point. That's a set thing. But as long as your material is flat and planar, which it should be for the laser cutter, then you're okay.
But you can take 7 different strengths and power settings. Speed power settings.
Right. And that's going to depend on what
Correct. So, laser cutters also go through a lot of stuff. There's some stuff that, you want to prototype with the laser cutter, these materials, probably, we can come up with something else. Number one thing is PVC, pipes, vinyl, you see on the side of cars, great material, super easy to work with. Unfortunately, when you burn it, laser or with a lighter, whatever you want to do, it's got fluorine gas. That's going to destroy both you and the machine. So, there's a couple materials that handle like HDPE, what your milk bottles are made out of. That's not going to cut, it's more just going to melt, and then we're going to have drops of fiery plastic coming down, and that's just, no good for anything. So, make sure you check what kind of material you want to use. You can do that by looking at MSDS. If you ever have some kind of exotic material, everyone's always coming with crazy materials. Check the MSDS. First thing you look at is the extrusion media. Make sure if you do start fire, you can actually put it out. You don't need any chemicals to put it out. If you look at the firefighting procedures or the risks, you can start seeing. You can see what it says. If it burns, they're really irritating, and irritating is a really nice word to say. Your respiratory tract, your MSDS is material safety page. So any material has it. So to wrap up, Medicare is awesome. Definitely encourage you to check it out. Check out videos online. Here's some things, especially I've got to upgrade this laser cutter to 120 watt laser, so we don't depend that it was woods, bones, pretty much anything that you can take a light or two or a torch to and burn through, you can cut precision wise. So afterwards, check it out. So next up is Richard. We're going to be talking about the mini PCB that you guys saw on the desk. If any questions, I guess we can do that.
Alright guys, so I do a lot of stuff here at the Makerspace, but one of the big things that I do is a lot of hardware development for small electronics and prototyping with the mini PCB mill. Let's get a go back there. So this is a little bit of what type of software is used typically for doing circuit board design and prototyping. We use a program called EagleCAD. It's pretty much the standard for people who develop hardware. This is a screenshot from one of the boards that I've designed for EagleCAD. It's a mini programmer for an 18x85 chip, basically like a mini Arduino. Then normally this stuff can be exported to a Gerber file and sent off to a fabricator to mass produce your boards. The reason we focus on doing prototyping on a mini CNC mill, if I send this off to a fabricator, it's going to take 2 weeks for me to get back to see if my design works or not. I can mill out the same board in less than an hour to test it out, so it definitely has a lot of benefits. This is the program that I'm using. It's a plugin that goes into EagleCAD called PCB G-code. It has a couple of different settings that you feed in there to tell it kind of what your machine's capabilities are. This is a little bit of information as to kind of how it machines out your PCBs. So these are end mills, which are used on pretty much every CNC mill to carve out material. This represents the actual PCB itself. The lighter yellow is kind of a non-conductive substrate, and then this is a copper layer. And all we're doing is we're just using this to carve away some of the copper layer in order to isolate our circuits. These are 2 different types of bits that are usually used for doing PCB prototyping. You have a straight end mill. This is really good because you get a consistent cut going in, but you're limited by the diameter of that spindle. This is what I use, which is actually a feed bit. So you can get a much smaller trace, and the deeper you go, the wider your cut gets. So you can get a lot of variety in terms of cuts without having to change out your bits. Also, these break very easily, and they are usually very expensive. These I hardly ever break. They're very, very robust and really long. This is an example of some of the G code that gets spit out. This is a visual representation of what it's going to do to isolate my traces. It just goes around. If any of you guys have ever worked with circuit boards, really all of these this is replacing all the wires that you would have in a breadboard. This is an example of some of the G code that the PCB G code plugin renders. Essentially, what G code is, every CNC machine from the laser cutter, 3D printer, and obviously the CNC mill works off of G code. So you have a nice interface that slices up your design, and the machine does its thing. But this is what's actually going on. You can edit them through just a basic text file. It just gives a series of coordinates that tells it where to go. I highly recommend if you get into circuit board manufacturing, learn a little bit of G code at least, because I constantly have to go in and repair glitches with it. It renders out a couple of different separate files. Usually the naming convention is something like etch. So etch actually isolates the traces. You have another one for drilling, which usually means you have to change the tools. And then you have another one for text, if you feel like actually putting text on your board. And then the mill is cutting out the board from the rest of it. So now once you get a prototype done, you have to go and probably before you go to mass production, you want to go to low-level production. I use OSH Park. They're just down in Oregon. And what they do is they work with a fabricator that makes lots of very large, full-size boards, but they do kind of something that, from my print experience, used to be done, where if you wanted a business card, you could buy tons of them, or you could go in with a whole bunch of people and do what we call gang press, where everyone gets a card and you get it for less expensive. That's what OSH Park does. So when you send them a board, you can send them a very small board, and then they add your board to a giant one with everyone else's project, and you can get down to like $5 per square inch. You do get 3 copies of each of those boards. So it's definitely a really nice low cost. That being said, this will also take 2 weeks for you to get up on board. So it's definitely the next step after prototyping. Now, once you got your board, next step is sourcing parts for building your actual electronics. Mauser, DigiKey, and Element 14. They're all companies that you used to have to run an industry in order to get in touch with, but they're pretty much available to anybody. And so you can order in batches as low as 1 per unit. They're pretty inexpensive. And then once you get ready to scale up, they are all set up to send you reels and to work with manufacturers. So you can actually start manufacturing. That's it. Any questions real quick? Oh, yeah.
So you don't have to remove all the copper between the traces?
You don't have to remove all the copper in between the traces, and it really depends on what type of circuit that you do. Typically, you want to do what's called a ground plane. So you're only machining out and isolating the traces that you need to, and all the ground is connected to the remaining copper. What that does is it helps to, mostly it helps as a heat sink. So if you're generating too much heat, it's able to bleed that away without having to add a heat sink to it. Yeah.
What's the minimum tracing space you get on that?
On this machine, I've been able to get it down to 0.2 mil. So pretty much about as small as I've seen like any of these guys build. Yeah.
You mentioned mill pad is made for going to use. Is there a specific reason why? Because a lot of programs software and Pro E do probably generate G code.
Yeah, so they can all generate G code, but a lot of those things are built for making machine parts. EcoPad is specifically for designing circuit boards. So you can go to DigiKey or Mauser or any manufacturer of a component or semiconductor or microcontroller, and chances are they already have a part that I can get from their library, place on there, and all of my pads and everything is set correctly.
All right. All right. Thank you very much, Richard. That's great.
So we got Jeremy. Jeremy's gonna talk about the larger CNC mill.
Just wonder about this. My name is Jeremy Hansen, and I do the hydroponic garden over there. I do some of the rework nation, work with wood. We build things out of wine barrels and pianos, and also do modeling in the space and graphic design, marketing, like that. And today I'm talking a little bit about the CNC router and the wood shop that we have here. First, I want to talk about what it's not. Oh no, now we have a demonstration. So this is something that we cut today, and it's using the V-bit, so it actually engraves, according to the one we just talked about, engraves the channel out, and it's good for engraving letters, kind of doing some script things. This is a carnival wheel for an upcoming escape room called Puzzle Break. You guys should check it out. They're up on Capitol Hill, and we're designing some puzzles for them. So CNC router, we get a lot of questions about what it can and can't do, so I just want to cover that. It does wood, plastic, foam, carbon, carbon fiber. It can do metal, but it's really not designed for that. You can do small amounts of metal, but with metal you want to have it lubricated so that it's going to be made, but it's really not set up for that. It also has some limitations. It goes up to 6-inch height max, and you want to do prototypes on this, but you don't really want to do production that it's not exactly quality. And then you also want to plan for several iterations. Sometimes people come in with 1 or 2 sets of materials, but there is a learning curve. Even with just clamping it down and getting it attached to the board in a way that'll cut without hitting things. Just build that into your planning. So what it's great for is precision cuts. Proof of concept is getting it out there and making your idea into reality. And then also jigs and pre-drilling, so if you have a lot to make, you can cut out the base that something sits in and pre-drill holes so you don't have to, where all the screws go, there's something that you get. It's also great for non-wettable materials, so some of those things that John mentioned that you can't cut with the laser, you can use this and it'll chip away at the material as opposed to overheating it. We also want to make sure you have the right bit there, because friction can melt some of those things too and expand the plastic. We don't want to do a little bit of research on the material. So we have 2 different programs for this. V-Card is the vector program that you can design in. You can also import vectors from another program. So if you have your own program, you can bring it into V-Card. V-Card turns it into G-code that runs the machine. And block 3 is the engine that runs this CNC router. And wood shop. We have a basic wood shop across the street. These are all the tools that we have. The table saw, planer, drill, chop saw. There's a router table, sanders, a bunch of hand tools, then saws and drills. So there's some minor manufacturing that we do. We have this capability. That's all available for a day rate of $25 a day. And we're also building out a metal shop. So we'll be having welding available for that, and classes and things. So we'll learn how to do some of these tools and create all of this work. Any questions?
So that software you're using for vector art, the most accessible version. If it's anything like my 3D printing setup, I've got some and stuff that you use to create a model, and you put that into Microsoft. There.
VCarve, you can design everything in VCarve.
Okay, so that does have a visual. But
Yeah.
But you can also bring in stuff from the software that you know, Escape or Blitz.
Yes. Yeah. Yeah. This is a pretty expensive one, and one that's even more expensive called Aspire. Yeah. Yeah, we do recommend that you do your designing and design your vectors on your own, because then you can minimize the time that you're at the machine. Just use that time to. All right.
So, yeah, that's pretty much all we have for today. Hopefully, we were something to get you guys ahead and turn in. Hopefully, if you have a hardware product, or everyone here might already have a hardware product, but you want to take it to the next level of manufacturing prototyping, and you're welcome to come into a shop like this. You can certify your any machine like this. But we want you to know that this exists in Seattle, and this is accessible here, and it's not going to be impossible to cut a block of wood out or 3D print something or even laser something out. Hopefully this kind of sparks your interest, and if you have any questions.
Do you guys do any work with molding or casting processes?
With what?
Molding or casting?
Yeah, we do. We are trying to work up a workshop and a better environment to do that. But a few of us have had some experience, and we've taught people on request, basically. Yeah. There's 3D printed and cast mold around it.
Yes, I was the other question. What are you guys working on for 3D printer? It's not 3D printer in there. Is there any background on that that you give us?
Yeah, so we kind of just really go into it, do it short and sweet. We're going to talk a couple minutes about 3D printing. We have several 3D printers set up. We're actually bringing in a very high quality, going out to design their own extruder and part of their own 3D printers, bringing in a whole batch of printers so we start doing more larger quantity prints.
Yeah, so we have, for right now, we basically have the MakerBots. They do work fairly reliably. They're pretty much limited to PLA, which is that kind of, it's manufacturer biodegradable, but it has certain properties that make it desirable for doing prototyping, especially for small 3D printing in a confined space. But the new printer that we're having is going to be able to do a variety of different materials, including PLA, which is what a lot of people like to use because of its properties of being able to polish it, along with stuff like conductive material and flexible material. One thing that we have that we mentioned, the molding and casting, one thing that we have been trying to work up is a workshop to show people how you can take a 3D printed object and do low run mass production by using that as a master to make a mold for casting. It's a common misconception people have, thinking that we can manufacture on a 3D printer. It's just not possible nowadays. It's too slow, too expensive per part. And so really you want to use that to make a prototype or to make a master to do casting out of line.
And another thing to say is that this space is always open. It's very much computer space. If we were having this amazing event, then there'd be tables set up here and see all kinds of different people sitting around here, from video game designers to people using soft goods on machines or whatnot. If you, I'll do something like that. This is both under here, but if you guys ever have, a class you want to do and you're looking for a venue to do it, I'm sure there's going to be a space for that. If you, for example, do casting, you have a class ready to go and you're just looking for a place to do it. And also we got, you're just sparked it.
Typically during the weekday, it's like anywhere from 9 until 6 during the weekday. I'm usually here on Saturdays from like 10 until 5.
Yeah, Saturday is KPs, so I co-founded with I run the question we had Bush School, which is a private school here in Seattle. we've gotten like 6 weeks or 7 weeks of programming with our instructors to build a blimp. Was a blimp that we semi-autonomous blimp. And the other thing too is we've had Amazon, Nordstrom, other companies come in and basically want some prototyping and actually have some education on Arduino and some developers on hardware and vice versa. So in all due respect, it's available for not just adults, but for kids too. We actually have kids learning modeling and design also here in the space. So we have busloads of kids coming in and learning about Makerspace and around that too.
So the goal now is to kind of help us finish the teaching of the year. We're going to be walking around. Do you have any specific questions? We're just curious.
What is the linear rate on the board?
Let me speak to that for a second. So I wanted to make sure that for a follow-up, so that anyone can look at specifics to know that and sign up on our website for any of the machines to be certified, also to reserve time on those machines in 15 minutes. To answer your question, all of our rapid prototype machines are $2 per minute. If we're doing the work, if you get certified, you can come in and reserve your time, and it's $1.10. The certification is $150 in each modality that we have. So we will discount it if you are doing more than one machine.
So you meant the feed rate for
Yes.
that? Okay. Yeah, it's about I think 60 inches per minute.
Yeah, I think so.
Ish, kind of. It depends on the material, really.
Material.
But I mean, it's not the fastest or most durable machine. It is definitely kind of a mid-range machine. So ideal for prototyping, not really for mass production. We do occasionally get access to a machine that can do far. It is an actual industrial CNC mill, but a lot of that depends on whether it's available. Thank you. No, all of our machines are on the free access.
So say one more thank you to Action.
Thanks. So Jonathan said, yeah, great to see us finally.
Yeah.
Here. So awesome. Thank you. Yeah, being pastor and support you guys to publish really cool projects on that. Everyone's becoming again more consistent. So we're just happy to be able to you guys here.
Yeah, thank you very much. Very cool. So check out the form. We have one, even a quick content you can go through and likewise to kind of show all your interest and get the build done. All right, thanks so much, everyone.
And I think the housing number I've got designed to go around. But before we think about mass production, we want to do low volume, or let's say low volume. And so more than just one or two compounds. So that's why I'm thinking about mass too. And I'm fine with this entire thing.
Yeah, but that and then you actually But the trade-off is you want to make nice sure that all your components and partners
This is not really detailed enough that this requires. Well,
but if it was a hollow block, you're doing like 1 millimeter here, 1 millimeter thick water around it. It'll be harder for that material to get down into that 1 millimeter. So it's probably if you're going to hold like 6 or 8 millimeters, that could probably
so I would need not optimal quality, but see what would you recommend? Well, so basically, imagine just an enclosing block like this that has rounded corners. That's basically the design. So the real design has many more features because it's a two-part section of the housing, but I don't care about the outside. So that can be basically wrapped up. That's fine.
With a lot of it, they're going to be going something a little bit more.
As far as
Or you can make many molds and castings. question was sort of like, okay, many can't many, like, you know, I want to divide it up into possible things, your time, an hour. I would want to make at least 10 molds so that I'm down to one part. Just get that and do 100 molds. The trade-off with that is that you know, buying a silicone is very much more expensive than
So for something like this project, you would use SoDo Makerspace.
yeah, actually, it is
And you 3D print the also.
yeah, I wouldn't recommend that. I know people are doing that, but you only get good quality. Whereas the silicone, for one, inside
Features that are, let's say, slightly less flexible, and I want to actually get the contour of this axe, right? So, you know, imagine you have a roll that's this basic dip this thing in a roll but I want that corner curve to be molded, so I can have a very cut mold with the top of the mold that stops it over here. And that means that on all sides, there's a little bit that's wider than the aperture. By something a little bit how you create a lot